This round, we're going to be kind of taking a look at something different. We're going to be looking at the units for 4 through 6, and this time we're going to be looking at flooding to start out. So, as you know, flooding, you get kind of wet, and flooding can cause a lot of issues. Okay, those of you who weren't paying attention to that joke obviously didn't like it and probably didn't even laugh. Or perhaps been flooded before and probably said, I didn't like that, Dr. Milan, but I've been flooded before. I've had a hospital that we had to evacuate with 66 patients, 67 units on scene. So I understand. Just a little light humor just to get started here, just to make sure you're paying attention. Flooding. Well, flooding costs the U.S. government billions of dollars per year in the efforts to mitigate against flooding, but also the cleanup that occurs after these flooding events also can have a high price tag on it and needs to take place. Let's face it, recovery is not the greatest part of writing a policy or being able to identify some of the great things like you do in mitigation or like when the event is taking place. However, recovery is a big aspect in trying to get back to what they refer to as normalcy. And if you have normalcy, you have a lot of happy people, including all the community stakeholders and the community players that are involved in this. But also, the flooding occurs not only with just rain, but it's a combination of things. It's going to be a combination of wind, rain, the initial push perhaps from the hurricane approaching the coastal areas that is going to cause this type of destructive flooding. In a lot of instances, we don't expect this. It might be a microburst. What's a microburst? Well, in essence, it's something that occurs or just flashes up due to the conditions that are right in the area at the time. Might be extreme humidity, might be a combination of cold and warm air clashing at the same time, and no one knowing that this microburst may occur. Well, it comes out of nowhere, and these microbursts that normally carry substantial winds. They also have torrential rains as well as creating flash flooding instantly. So this microburst might cause flooding as well, unbeknownst to any emergency management personnel or even weather personnel. You just on occasion you'll see these things flare up on the radar and say, "Uh-oh, here it comes," and you have just enough time for a warning to get out or perhaps get things organized just in a nick of time in order to respond to whatever this microburst is going to give you. But flooding is the most common disaster here in the United States, and that's the one that's causing most threat to life and property out there. We can see with the coastal flooding, and flooding doesn't have to happen just from torrential rains or from a hurricane that might be approaching. You might have a storm surge with that hurricane, as you're probably well aware. But also we have this little thing possibly called global warming. And these nice little polar ice caps continue to melt, and it does cause an issue for us regarding the water levels beginning to rise. A lot of these lakefront and beachfront properties that are there, we can see actually now with the Great Lakes, for example, that erosion is taking place, and the water levels are at their highest levels ever historically since we've been taking those water level measurements. The same thing is going on with the coastal flooding too. The water levels are rising due to the melting of the ice caps. The water has to go somewhere, thus causing flooding. So basically, flooding is costing the U.S. government billions of dollars per year. Flooding can occur with a combination of wind, rain, hurricane force winds, as well as having storm surges. And flooding is the most common disaster that we are going to have here in the United States. And that's going to be the biggest threat that we have to our lives as well as our property. In our next slide here, slide 2, floods are generally caused by some of the following, and not just limited to these areas, but it's going to be caused by dams collapsing, flash floods, which I mentioned in the previous slide, perhaps flooding after a fire. Now you're going to say, wait a minute, we just had a fire, it just scorched the earth, now how are we supposed to get flooding after a fire? Well, if a fire happens to come through, scorches everything in its path, and there are no trees, there's no any type of material that's going to be blocking a deluge of water that's going to be coming down, perhaps makes sense that it might run downhill and water is going to seek its own level. So if it happens to be a torrential rain even after a fire, then you're going to have even a problem. And the water that's going to be created with this is going to be very murky. Why? Due to the fact that there's a lot of ash and a lot of cinders that'll probably be still perhaps smoldering or burning if it happens to be right at the time that this fire has immediately pass through. So keep that in mind. Just because there was a fire there doesn't mean that the water is not going to rush through. And again, that's due to the fact that there isn't anything there to assist in blocking it. Ice jams, La Nina, levees collapsing, mud flows, new developments, new subdivisions going up. The flood that we experienced with our hospital back in 2007, I can tell you that it's partially due to the fact that it's in a concrete jungle area, literally, and due to the fact that all the fields that were around this place are now paved over for parking lots, have been built with buildings and other rec areas and things. There's no place for the water to go, basically. Where's the water going to go? Into our emergency department, as well as another 200,000 square feet of our main floor in the hospital. So just because you don't think that it can happen with new development and it looks nice out there with new developed subdivisions and homes and buildings and things, the water still can come up through sewers. And if the sewers can't handle it, it's coming up through the sewers and it's going to invade your location. And that's the way that works. Snow melting, spring thaw, tropical storms, hurricanes, and a rainy winter season are all some of the contributing factors there. And then, of course, you have coastal flooding, which I mentioned in the previous slide. But a rainy winter season, it's not uncommon. I'll give you an example. For example, in my area here in the Chicago area, it's not uncommon for us to have a mild winter where we might not have that much snow. However, we might have a lot of rain. And then in January, the ground freezes and it's solid, perhaps 6 to 8 inches at least with frost line. And then all of a sudden it starts to rain again and the water doesn't have an opportunity to sink into the ground because it's frozen. The water has to go someplace. It remains up on top, and again, it flows into our rivers and lakes and streams that we have nearby here, and it does pose an issue because, again, it's frozen, and the runoff doesn't go where it's supposed to go into the ground. It just stays stagnant and on top, and thus a lot of flooding can occur during those times. So once again, flooding is generally caused by a quantity of things here between dams collapsing, flash floods, heavy rains, ice jams, La Nina, levees collapsing, mud flows, dogs and cats living together, mass hysteria. But my point here is that snow melting as well as your spring thaw can also be inclusive for flooding, depending on the area that you're in. And once again, tropical storms and hurricanes more along the coastal areas, and then having a rainy winter season, much as the example that I gave you here for the Chicago area, can take place and create a lot of flooding issues as well. Continuing with flooding, it seems like a perpetual thing, but it's a very important thing for you to understand, seeing how is the number one issue that we face as far as disasters are concerned here in the United States. So another potential danger for flooding is the aging of our 84,000 dams that we have here in the United States. And you're thinking, well, what does that have to do with anything? They're supposed to help us. Well, aging infrastructure such as dams can create havoc. And 1/3 of these dams is more than 50 years old. So if you can imagine that, if my best example to this, if you can imagine placing yourself outside and standing outside for approximately 50 years and not taking care of yourself or treating yourself the proper way, on occasion fixing yourself up with a Band-Aid approach to whatever, due to financial obligations perhaps, think about how you would look and think about how you would function after something like that. So my comparison here is that, yes, you would probably feel miserable and skin cracking, etc., etc., but much is the same thing as a dam that's out there, and it's underwater, and it's blocking things, and it's out there in the elements all the time. And sometimes there is a lack of funding. That lack of funding will not be able to create perhaps a new facility, or perhaps tear down the one that's there and build a new one, because it costs a lot of money. And many of these agencies and cities and towns and states don't have that type of money. They'd rather put a Band-Aid approach on it as long as it's the safety factors there. So about 2,000 dams here in the United States are deemed as unsafe. That's a lot of dams. And one scary thing is dealing with rushing water. It's a not a pleasant sight for one, watching the water come at you, but two, the eerie sound of this rushing water coming to you when you know it's coming, and there's absolutely positively nothing that you can do about it because you know what the result is going to be. And in this case, if these dams continue to age and are not fixed, some of these are going to become weak and weaker, and eventually they're going to crack. And even if there's a slight crack in the foundation, the amount of pressure behind those dams and those walls can make a significant impact on a lower lying community, as well as creating a surge of water that is very, very um, strenuous, if you will, once it's being forced through from those dams. And those streams are then becoming overwhelmed, and then the excess water quickly fills those reservoirs. Again, if there's no place for that water to go, it's coming for a visit, and unfortunately, it's not going to be a nice visit due to the fact that there's the rapid rate of this water that's going to be pushed out from the foundation of this dam is going to create a surge, much like you can see from a hurricane, but also it's going to be carrying a lot of things in it, and it can carry debris. Obviously, it carries cars, it can carry boats, whatever is in its path. It's going to push it because that water is rushing at such a high rate of speed. The velocity itself is going to destroy homes that may be in its path, splinter wood, shingles, whatever it may be. And if you think that you're going to escape this path of water, guess again, because it's very difficult to do so. The majority of the time, as a side note, the majority of the time, most victims that are involved in these rushes of water, for example, if it's a tsunami or a surge, they're not dying from drowning. They're dying from the debris that's hitting them. And it's all the things. And for example, on the coastal areas, if a person happened to get hit by a part of a pier or a dock with this rush of water, that's going to cause a serious injury, if not imminent death. So most of the time, it's not from drowning; it's going to be from the debris that's inside the rush of water. And if it's coming at you at a rate of 55 or 60 miles an hour, and you happen to get hit by an automobile, or if it's part of a house or whatever it may be, that's going to be the situation there. So I think you understand where I'm coming from. So the potential danger here is that we have aging infrastructure in regards to the dams. We also have 84,000 of those dams in the United States, and over 1/3 of them are deemed as 50 years or older and deemed unsafe. And then you have 2,000 of those that are definitely deemed as unsafe. The infrastructure is growing older, it grows weaker. The potential of this risk of flooding and imminent dam breaking then is going to continually go up. And that's when all of a sudden the streams and the reservoirs, etc., are going to be overwhelmed. Now you're probably guessing in the next slide here that some of the questions that are often asked about flooding. How are human-made floods caused? How are the river basins affected by changes that are made by humans out there? And how does rapid urbanization make an impact upon communities out there? Well, the first one, how are human-made floods caused? We kind of touched on that in the last slide in dealing with the dams and the levees. If the dams and levees are not looked at and not inspected, then you're going to run into an issue with perhaps them being breached and having another flooding issue there. And then the river basins affected by changes. How do we do that? Well, and you can just well imagine that we change the flow of rivers sometimes, and we change the directions of our river flow due to the fact that we're looking at economics, and we're looking at building subdivisions and different types of strip malls and perhaps a new automobile dealership, etc. And all this contains an issue of where's the water going to go. And you need to be aware of that and see whether or not this is going to be actual wetland, perhaps that can be saved in order for this water to have proper runoff and drain off, or if this is going to be something that is going to be not economically stable and perhaps convince otherwise. But a lot of times The changes that are being made are by land developers, of course, and putting subdivisions as well as some of these strip malls. That's the most common that takes place. And then rapid urbanization. I kind of touched on that in the previous slide as well as in the previous bullet point here. But it definitely makes an impact upon minimal runoff opportunities. Where does the water go? Again, the water is going to seek its own level, and those are some of the considerations that you need when you're constructing, or if you happen to be building something. Are you in a floodplain? Are you in a flood zone? When was the last time that this area flooded? Is this a 100-year flood zone area? Is it a 500-year flood zone area? And is this year 499? You have to make sure of all these things when you're constructing homes. Is flood insurance available? That's a big thing too, because if it happens to just be in a floodplain, you may not be able to get flood insurance due to the insurance company not wanting to take a high risk such as that. All these are considerations when you're looking at constructing something, or if you're in the construction business itself, and being able to make a new facility over there. So again, some of the questions that are out there, how are the human-made floods caused? What are some of the reasons why the river basins are being affected by human-made actions, and some of the urbanization issues there? Why are some of the communities being impacted by many of these floods, most recently due to the lack of runoff opportunities? And those are some of the key elements on this slide here. So in our next slide, we go from water to wind. We're still in W, but we went from WA to WI. So we're going to tornadoes in this one. And yes, rain is associated with this. And yes, flooding can occur with tornadoes. It's not just the wind. It's not just going to occur in perhaps one little location where flooding can occur. It can occur in areas that are a mile and a half along the path of a tornado. So a tornado, as you probably are well aware, is referred to as a twister, and is also another natural disaster. The natural hazard here originates from a thunderstorm and then forming a cloud formation that appears in the shape of a funnel. I'm sure you're all well aware of that, but I just wanted to make sure that you have the basics and the foundation pertaining to tornadoes. Now, tornadoes are closely, related to, or they follow along the same path of a thunderstorm that forms when it's warm. You have dry air from the western U.S. and then meets the warm, moist air traveling from the north of the Gulf of Mexico. So obviously it's coming from the south. So you have this combination of air and these air masses, and once they get together, that's when the conditions are right. You'll probably see, if you haven't been in a tornado before, you'll probably see a greenish tint to the sky. You'll hear dead silence for a little while, and then all of a sudden there's this burst of air that comes, and very, very torrential rain that is going to be associated with that. Hailstones are not uncommon. It's just going to depend on the type of storm that this is going to be. But the wind speed of those tornadoes can reach a huge mile per hour rate of 300 miles an hour, as well as the potential for leaving a destructive path as far as a mile and a half wide, and then approximately 50 miles long. That's what we're referring to when we have our F5 tornadoes, etc. These are very powerful storms. They're very unpredictable in most cases in which direction that they're going to be traveling, as well as you will notice that some areas with these tornadoes, they will skip and jump over some subdivisions. The house right next door may be destroyed. The one right next door to that might just be fine with very minimal damage to the outside and perhaps the roof. It just depends. These storms are very tricky, and that's why they call it a twister. It twists from side to side. It doesn't normally take one solid path. Whatever's in its path, depending on the type of strength that this tornado has, it will definitely make an impact and definitely create an emergency situation for emergency responders as well as other people. So again, tornadoes are referred to as twisters. They appear like thunderstorms, but they also come out in a shape of a funnel. They're closely related to the thunderstorms. much as it's when they're starting to form, as warm, dry air from the western states, and then you have the warm, moist air that's coming from the southern Gulf area. And then the wind speeds can be an excessive rate of approximately 300 miles an hour, as well as providing a path of destruction as wide as 1.5 miles and then 50 miles long. And that's pretty wide when you're dealing with communities and several homes that are being built in these subdivisions. So those are some of the main points on this particular slide. So looking a little bit further here in tornadoes, the first responders need to be sent to those areas that are impacted the most. I go, well, obviously this is my 1980s moment. Duh, yes, of course they do. This is the reason why they need to be sent out there, is because an event had taken place. In the event that a tornado will strike, then you have a well-populated area, which is hopefully not going to happen, but a lot of times it does, where these twisters are going to come through. And then there's going to be several people working in multiple locations to help remove trapped people that may be stuck inside debris. Now, on many occasions, most normally, tornadoes are going to occur during the daylight hours. However, we do have tornadoes that occur in the wintertime. We do have tornadoes that occur at nighttime, which is probably one of the most scariest times because you can't see it coming. All you can do is hear it approaching you, with it being dark as night. But however, one good thing is that if there's a lot of lightning that's going to be associated with it, you have an opportunity to see where this thing is. Maybe you don't want to see where this thing is approaching. However, I have a tendency to not like to fight something that's invisible, and know that this is approaching and being able to see where this is landing as such. But keep in mind that it is going to be flexible, it is going to be a twister, and it's going to change at an instant. And there also may be a need to have medical personnel that are going out there at medical facilities, keep them on high alert to deal with some of the casualties that can be involved with these tornadoes. And if a tornado happens to be on a large scale, then the likelihood of wide-scale destruction will definitely increase. Makes sense, and it's common sense. If you do have an opportunity to watch some of these tornado videos and on YouTube, as well as some of the specials that they have with the Weather Channel, especially during the springtime, this is a good time to kind of take a look at them and see what you may be up against, especially if you live in an area that's highly prone towards tornadoes, and some of the areas that you are most impacted by. If you happen to be in a rural area, or if you happen to be in a more populated area, and see how it's going to work in your area. But one thing that's interesting is that there's been a theory out there, and I can't remember where the theory came from, but there's a theory that states that larger cities, due to the amount of heat as such, and the amount of pollution that's generated from the major city, has a tendency to ward off tornadoes. Now, I don't know if that's an actual theory that's been proven or not, but in general, from what we can see, and knock on wood, this does not occur, especially after making this recording for you all. But there's a subject matter out there that demonstrates to where it does not occur in heavily populated areas, such as a major city. Now, a heavy populated area outside in a suburb, that has a higher risk for whatever the reason. Interesting concept, but I don't want to see it proven. I just want to make sure that you're all aware that there are theories and theorists out there that have kind of dispelled and have also demonstrated that this myth, or perhaps fact, is out there. But keep in mind, first responders are going to be out there after the tornado strikes, if not ahead of time, to make sure that people are all right. And then also there's going to be a need for medical personnel at the facilities, at your hospital facilities, as well as some of the situations that are going to arise out in the field. They may need a field hospital due to the devastation or destruction that may have occurred. So those are some of the main points on our slide here for tornadoes. Now, depending on the type of situation that may arise, there may be a need of a mobilization of engineers and construction crews. Pretty much public works, that bullet point right below that. Public works will be very beneficial. You're saying, well, public works. Normally, public works, we're thinking, that's the parks, and it's dealing with recreation, and it might be dealing with some of the construction that goes on in the city and that. Well, public works have these wonderful machines that chop trees and chew up trees. And if trees are blocking pathways for ambulances and fire trucks and fire personnel to get from one place to another, same with police officers, that's going to make things a little bit more taxing and a little bit more difficult. Thus, it's going to be imperative to have a great public works department and include them in on any type of planning that you may have. The other thing is that the emergency manager has a communication plan that will not only inform the community members, but also it's going to address the news media about the updates. One of the things that the news media does not like is not having any type of an answer or just saying, I'll get back to you, I'll get back to you. That demonstrates that you're not really on top of things. However, if you give them some type of information, if you provide them with a little bit of an inkling as to what is occurring, that will appease them for that moment, and then you'll need to go back and follow up on some of the things that they had asked, and then come back to them with an answer at perhaps the next debriefing that you have. So depending on the situations, there's going to be a need for mobilization of engineers, public works, as well as open communication. And social media plays an integral role in that open type of communication, because so many people already know what's going on out there even before the emergency manager or the incident commander has an opportunity to set stakes out in the field and say, okay, now let's start to get to work. So these are some of the main points here for slide 7. One of the main things I'd like to bring to your attention here dealing with tornadoes is the fact that some of them can be just downright nasty, and that's the twister of all of this. On May 22nd, for example, 2011, EF5 tornado struck Joplin, Missouri, injuring 1,000 people and killing 158 people there. And then disaster ranked the seventh as one of the most deadliest tornadoes in U.S. history, with the wind speeds at 200 to 250 miles an hour, and then 3 separate vortexes within a mile-wide traveling funnel. That is just incredible in itself. Normally, you're only going to get a vortex that is going to have 1 twister out of it, let alone 3 twisters that are going to be coming out of it. That is one powerful storm. That is one mean storm. And it's amazing to see that only 158 people were killed in this storm. I mean, losing 1 life is bad enough, but in the magnitude of this storm with an EF5 and then going to 200 and 250 miles an hour and then 3 tornadoes in 1 vortex, that's a miracle in itself. And then 300 yards wide and traveled for 13 miles, struck for 24 minutes after the Joplin residents received the tornado warning from the National Weather Service. And that's incredible, 300 yards wide as well. That's almost, 3 football fields in length. And you can imagine the devastation that was on there. It's been said that the hospital that was there in Joplin was literally lifted off of its foundation, and the tornado moved it approximately 50 feet off of its foundation. That's a lot. When you pick an entire building up and you move that building 50 feet off of its foundation, that should tell you that is one fierce storm, and that describes the magnitude of that storm. And this is something not to be joking around with. So when you do hear that tornado warning or that tornado watch, be on alert for something in the area. And if you have a tornado warning, I would humbly suggest that you take cover, because you don't know what's going to occur. And a lot of times these tornadoes pop out of nowhere, much like a microburst, and there's a lot of issues that are going to be surrounding this. So just keep in mind that the Joplin tornado is one of the most fierce storms that's been ever recorded on record, with maximum winds of 200 250 miles an hour, and then this thing was approximately 3 football fields in length, causing much devastation. So keep your eyes and ears open, especially in the springtime or in the volatile areas. Even with hurricanes, tornadoes are associated with hurricanes. Why? Again, warm and moist and dry air that are going to be combining with one another, and you have tornadoes that can be spawned from hurricanes as well. Here on slide 9, and this just kind of gives you an idea of the magnitude of the tornado. So it goes from 0 to 5, EF, and that's going to be your rating here, and then you have your wind speed. So for example, if you have an EF 0, you're going to be going from 65 to 85 miles an hour with wind speeds. So there's a lot of times that we have wind gusts that'll go up to 55 miles an hour, 60 miles an hour. But in an EF0 tornado, that's already starting to make an impact. And then you can see the rest of the figures that are there. The EF5 tornado that we just discussed for Joplin is at the bottom of the list there, over 200 miles an hour. That is some very, very powerful wind, as well as being able to throw debris in the air for miles. The most common, I would say, that we have experienced would probably be EF1, EF2, and that'll depend on the type of atmosphere once again. But between 86 and 110, and then 111 to 135 miles an hour, that's normally what you will be experiencing, depending on your area and depending on your region. Now, if it's a little bit different, if you happen to be in the tornado belt, well, you might fall into that EF3, EF4 category on more than one occasion. But hopefully, this graphic here shows you and demonstrates to you that these are very potent, and it can range from 65 miles an hour to over 200 miles an hour. And if it isn't bad enough between flooding and wind, let's just throw a heat wave in here. So you go from all those disasters to a heat wave. Well, what do you need to consider when planning for a heat wave, aside from hydrating yourself at all times? Well, the failure of power grids and the cost of additional power to fuel during these excessive weather conditions are definitely two of the concerning factors that we have here. So the cities are going to need extra power, extra energy. They're going to have to understand that these might be overloaded, and there's going to be a lot of air conditioners that are going to be needed, that are going to be running during this time. And then you have to evaluate the response capabilities, explore what the community resources are and how they're going to develop an emergency plan and a contingency plan. The time for a contingency plan is not in the middle of the heat wave and not when the power grids go down. So there has to be numerous resources and also an evaluation that takes place prior to a heat wave occurring. It may take a coalition for emergency response and being able to meet with all the players and sit around the table. And even with the coalition of emergency response, aside from just meeting, it might take a tabletop exercise in order to sit there and talk out some of the things and some of the ideas that need to be addressed dealing with a heat wave. So in order to move forward with any type of congruency, you need to understand that you're going to deal with issues of failure of power grids, additional power being needed, fuel these excessive weather conditions due to the fact that they're are coming from the west, and it may be dry and it may be long. We experienced that heat wave here in Chicago almost 15, I think 20 years ago. I'm losing count. My voice hasn't changed, although I have aged. It hasn't changed yet, but this has been a while back when this heat wave took place here in Chicago. And then you have to evaluate the capabilities that the local emergency managers have, the state emergency managers, and then dealing with developing a solid foundation with a contingency plan one, and then having a very solid foundation with your emergency management plan in dealing with that type of thing during a heat wave. Furthermore, with heat waves, you look at the heat wave index from the National Weather Service, NWS, and the excessive heat outlooks are going to be issued when there is a potential for excessive heat within the next 3 to 7 days. And the National Weather Service has come a long way since that heat wave that we've had here in Chicago, with being able to predict these heat waves, identifying how long they may last, and even predicting what time of day is going to be the worst. Excessive heat wave watches are now issued when there's going to be a potential for excessive heat wave within the next 24 or 72 hours, much like a wind advisory that may be posted or a freezing rain advisory within the next 24 to 72 hours. The same thing is going to be applicable to heat waves. And then excessive heat warning advisories are going to be issued within 36 hours of the onset of extremely dangerous heat conditions. As you can see, there's many fail-safes over here that need to be identified and being able to watch for when a heat wave may be coming, especially from the National Weather Service announcing it, and then looking at that. When is it coming? Is it within 3 to 7 days? How to prepare for it. Excessive heat watches then are going to go into effect within 24 to 72 hours of the event, and then the excessive heat warnings and advisories are normally going to be issued within 36 hours of the onset of extremely dangerous heat that's going to be coming. Adequate warning, adequate provisions, as well as recovery efforts that are out there all need to be taken into consideration. Speaking of Chicago, let's talk about Chicago. So July 13th of 1995, Chicago experienced an increase in temperature, which is not uncommon for us over here in Chicago. We begin in the middle of July and run through August, where it's excessive heat, sometimes humidity, and it's a combination of both. However, the temperature started to increase and range between 90 degrees and low 100s during the day, and mid 80s during the night. Now, mid 80s during the night, especially here in Chicago, is very soupy, as we like to call it here, and it's very muggy, and it does pose an issue for those who do not have air conditioning. So the daytime heat index eventually made it to approximately 120 degrees, where people were living inside homes and apartment buildings in close proximity that did not have any air conditioning, and you can imagine just how uncomfortable and how dangerous it was. And then as the heat index increased, then the death toll continued to rise until the heat wave finally ended on July 20th. So we had one solid week of humid and extremely hot temperatures that caused resource depletion, as well as numerous people that had passed away. So the resources were depleted due to the fact that they were not prepared initially for this type of event, and then this heat wave resulted in approximately 739 people in July of 1995. That's a lot of people, and it's even with going and providing them with cooling shelters and fluids and checking on them to make sure that they're okay. It just depends on how the person is going to adapt with this. And then how do you prepare for something like this? Well, it's kind of like what you're doing with flooding and tornadoes. You're going to kind of look at the weather report, and then you're going to be looking at how to plan and develop your local jurisdictions. Well, how do you plan with local jurisdictions? You actually have to meet with these people and communicate with them. Yes, it may be difficult at times to get everybody on the same page and meeting all at one location, but as long as you're able to get stakeholder buy-in, you'll be fine. And then collaboration with shelters, gymnasiums, and other locations too. Churches are a great form of cooling shelters as well, because normally churches have an opportunity to have basements. They also have locations that have food shelters and food pantries, etc. And they're an awesome way to assist those that are in need. The ARC, American Red Cross, and Salvation Army are out there to assist as well. They may have several buses, trailers, etc., that are able to be moved out portably, and are also being able to be used by those in need, especially the homeless. And also you have volunteers. Volunteers are the key to successful operations at any place. We have so many different types of resources in communication and technology and social media and what I refer to as the neat toys that are out there that we're able to use. But when this is a natural disaster and it's a heat wave that's coming out there, technology really can't give us all the benefits of cooling a person down. Although fans can, but you get my point when we're dealing with social media, as well as using computers to help us fight against something like this. We know ahead of time now that heat waves are coming. We know what to anticipate as far as the main threat, the time of day, and if there's going to be any severe thunderstorm outbreak or issues that can occur. But we also need to know that collaboration is going to be key with shelters, gymnasiums, and churches, for example, as well as working alongside the American Red Cross, Salvation Army, and other organizations. And volunteers are going to be the backbone of any operation, not just dealing with heat waves, but dealing with flooding and tornadoes as well. And finally, looking at the heat wave, we can only prepare. We only can do what we can do with the resources that we have provided with one another. And communication is key. Communication, as we all know, in exercises as well as dealing with our disasters, communication is going to be the first thing that fails. So working alongside one another initially in dealing with communication and having a backup to the backup, that will be a very key component. Identifying some of the social structure of the community, meaning that identifying the cultural context of the community, the socioeconomic status, the age groups, and locations. You're saying, well, wait a minute, how does that kind of fall into that? Well, so you have underprivileged and underserved neighborhoods that might not get the message. They don't have access to internet. They don't have access to computers. They only can go to the library and being able to use a computer for free, for example. Well, during a heat wave, not too many people are going to try and meander or wander out to go use a computer. They're going to stay in their designated location. And a lot of times it's going to be difficult for them to get to the information due to the fact that they don't have any form of media or a very antiquated form of media that will not provide them the opportunity to listen to what is actually occurring out there. And then the capability of the power grids, the availability of water, food, and community shelters that are going to be out there, but also in searching how these community shelters are going to have a proper means to take care of these people. Community shelters on an annual basis should be revised and looked at. And the populations that are out there that are continually expanding, thus the vulnerability is going to change and is going to shift as well. Many times things are just status quo, and we have to, what I refer to as, blow the dust off the policy when the time comes and say, okay, well, that building is no longer there. These people are no longer working here. They've long since retired, whatever it may be, and these phone numbers are out of date because the extensions are different, or the mobile numbers are no longer in force. So all of these things need to be considered when you're dealing with a policy and preparing for a heat wave. And then finally, the last one is dealing with mortuary services. Much as we've seen from pandemic flus in the past, that mortuary services are going to be very, very critical and key elements. It's something that we all don't like to talk about and don't want to bring up, but very important when dealing with the deceased and being able to respectfully place them at rest and identifying identifying them when the time comes. So mortuary services are definitely something that most people don't like to discuss in any type of mitigation plan, but are going to be very necessary. So how do we prepare for this? Just to kind of summarize everything that we've learned on heat waves, you need to prepare. You need to communicate with your community stakeholders. You need to identify the social structure of your community, identifying any kind of cultural context, socioeconomic status, as well as the age group and the locations of those people that are located in your community. And then the ability of the power grids to withstand the over-reliance on air conditioning and air conditioning units and cooling centers, as well as where water can be found, what type of food is out there that's available, as well as the community shelters requiring an annual update and an annual evaluation to make sure that the people that are still heading and spearheading these organizations are still working there, still have an opportunity to identify what needs to be done, and also to check the communication standards. What phone numbers are still viable, what phone numbers have been changed, who is retired, who has moved on to bigger and better things. All these need to be looked at. And finally, looking at the mortuary services in order to respectfully handle the deceased in here. So with that, I thank you for your participation and watching for our heat wave flooding and tornadoes for our sections from weeks 4 through 6. I do look forward to working alongside you in the upcoming weeks, as well as working alongside you here in Collaborative Session 3, which will cover Units 7 and 8. I'll get those posted up. Also, the video link for this will be posted up in the announcements section as well, so look for that special recording. And I do wish you well. If you have any questions, you all know where to find me. And you feel free to text me as well, because you all have my information. So once again, thank you so much for attending the session this time around, and you all have a great week.